All right, y'all. Today we're going to be talking about infinite limits. So we've been talking about graphical limits, so limits that we can evaluate by looking at a graph. And we've talked about algebraic limits, limits that we can evaluate by plugging in the value of x. And today we're going to talk about infinite limits, which are limits where either graphically or algebraically they equal infinity, or the limits are doing things by going to infinity, that sort of thing. So we're going to start with number one. So we're going to graph f of x is equal to 3 over x minus 2. And then we're going to find each of these limits. And we're not going to worry so much about graphing by hand today. So all the graphs we're going to use a calculator for. So 3 over x minus 2, even though I'm sure you could graph it by hand, we're going to graph it real quick. Maybe. There we go. 3 over x minus 2. As we can see, it's a nice rational function. It's got a horizontal asymptote at 0 and a vertical asymptote at positive 2. So we're going to add that onto our graph. All right, and there we go. So now we can talk about, now that we know what our graph looks like, we can talk a little bit more about each of these limits. So we have the limit as x approaches 2 from the left side, and we have the limit as x approaches 2 from the right side. So the limit as x approaches 2 from the left side, I'm going to follow my function, and as I go from the left, the value that my function looks like it's going to is it's going down. That arrow means it's going to continue on forever, so it's actually going to approach negative infinity. And then likewise, on the right side, when I'm approaching 2 from the right, I go to my right side function, I approach positive 2 from the right, and my function looks like it's going towards positive infinity. So infinite limits are limits that equal infinity, and the first case we're going to look at is we're going to look at functions that have vertical asymptotes, because we've already been doing a lot about vertical asymptotes, and we know that functions at vertical asymptotes approach them without crossing them, and they go towards positive or negative infinity. So for each of our functions below, we're going to find the single real number c that is not in the domain, probably the vertical asymptote, and then we're going to graphically find the limit of f of x as it approaches from c from the left and from the right. Okay, so we have f of x is equal to 3 over x minus 4. So just like we've done before for our rational functions, we set any factors that are in the domain equal to 0. So x minus 4 is equal to 0, which means x is equal to 4. So 4 is the c value that we are now evaluating our limit at. So we're going to evaluate the limit as x approaches 4 from the right and as x approaches 4 from the left. So we're going to go back to our calculator real quick. What was our function again? 3 over x minus 4. And we're going to graph. And so just like the one we saw before, we can see our function approaching from the left goes down towards negative infinity, and from the right goes up towards positive infinity. Hey, so relatively straightforward. I'm going to let y'all try number 3 and number 4 real quick on your own. So pause me, go ahead and try those problems, and then unpause me and I'll talk about them. All right, y'all. So we can see number 3, we set that 2 minus x equal to 0. So the x value we're looking at is 2. And when we look on the graph, because of that bottoming backwards, the 2 minus x instead of x minus 2, it does actually end up kind of flipping our rational function, which is why we approach negative infinity from the right and positive infinity from the left. Number 4, we have negative 3 over x plus 2 squared. I know this one can be confusing, but we just set the single x plus 2 equal to 0, so we get x equals negative 2. And then when we graph this one, we actually see that both sides of the rational function go up towards positive infinity, so it is positive infinity and positive infinity. So let's have a little bit more practice finding vertical asymptotes. So vertical asymptotes, as we remember, occur at the number where the denominator is 0. So we set those factors in the denominator equal to 0. So we want to determine all vertical asymptotes of the graph for each of these functions. So we have 1 over 2 times x plus 1. So first thing we want to do is we want to set any factors in the bottom equal to 0. We have that 2, but it doesn't have an x, so we're not going to do anything with it. So we're just going to set that x plus 1 equal to 0. Minus 1, and that gives us x is equal to 1. Let's look at 6. We have x squared plus 1 over x squared minus 1. So this one we have to do a little bit of factoring. X squared plus 1, I can't factor that into anything, but x squared minus 1, I can factor into x plus 1 over x minus 1. So I'm going to go ahead and do that now. And then any factors that I have left over in the bottom, I can set equal to 0. So x plus 1 and x minus 1. And x minus 1. And there we go. So we get x is equal to negative 1, and we get x is equal to positive 1. I'm going to let y'all practice number 7 real quick. Give yourself just a little bit of practice. All right, so as we can see on 7, we factor both the top and the bottom into x plus 4x minus 2 and x plus 2x minus 2. And then that x minus 2 and x minus 2 cancels out, so we don't get an extra vertical asymptote from that one. We actually get a whole from x is equal to 2. So the only vertical asymptote we actually get is x is equal to negative 2. Okay, so let's go ahead and put everything we've been doing together, okay? And we're going to actually find some of these limits at vertical asymptotes. So we're going to look at number 8. We're not always going to have a calculator. So if we don't have a calculator, we can still use some of these skills to find these limits. So we have the limit as x approaches 1 from the left of 1 over x minus 1. But we're going to assume to start out, I don't know this is going to be a vertical asymptote. This is in the notes. I'm just going to run into this problem. So what am I going to do? I'm going to go ahead and take 1, and I'm going to plug it in first, just like I would for my algebraic limits we did last class. So 1 over 1 minus 1 is equal to 1 over 0. So that 1 over 0 is no good. That is an undefined value. I can't divide a number by 0. So that means I need to go back and I need to look at my problem to try and figure out what's going on. Usually when I'm dividing by 0, that means that I have a vertical asymptote in my problem. That's the issue that's occurring. So I'm going to go back. I see x minus 1 is in the denominator. So I'm going to set x minus 1 equal to 0. Add 1 to both sides. And we get x is equal to 1 is my vertical asymptote. Okay, so now that I know it's a vertical asymptote, I know that my function is going to go towards positive infinity or negative infinity at a vertical asymptote. That's what I know. I know it for a fact. We've seen it with our graphs. We've seen it with the various different functions that we've done. So now that I know it's going to go towards my vertical asymptote, all I need to know is it going to be positive infinity or negative infinity? So I've already narrowed this question down to only 2 possible answers. And to determine which infinity it's going to be, I'm going to plug a number in that's really close to my vertical asymptote, but still fairly simple to plug in. We remember we did this before with rational functions when we were testing the limits. So the number that is just to the left of 1, and I'm doing just to the left of 1 because of the negative sign, I'm approaching this limit from the left. So just to the left of 1 would be 0. So I can plug in 0. So 1 over 0 minus 1 is equal to 1 over negative 1. 1 over negative 1 would be negative 1. So negative 1 is going to be going down towards negative infinity. Okay? And this is because as I get closer, I could plug in another number. So let's say I plugged in 0.5. 0.5 would even be a little bit closer to the asymptote. It would give me 1 divided by negative 0.5, which is equal to negative 2. I could plug in 0.1, which would give me 1 over negative 0.9, which would be equal to negative 90. So it would get closer and closer and further down as I get closer to my vertical asymptote. So this would tell me that I am going towards negative infinity. So that is kind of how we're going to do these. There's kind of two steps to them. You plug in the number first. Okay, once you plug in the number, if you get that divide by 0, you know that you need to go back and look for a vertical asymptote. If you find a vertical asymptote, then you know that the limit is going to be either positive or negative infinity. And once you know if it's positive or negative infinity, you're going to plug in a number just to the left or just to the right, depending on the limit. Okay, and then if that number comes out is positive or greater than the horizontal asymptote, then you're going to be going up towards positive infinity. If it's negative and below the horizontal asymptote, you're going to be going down towards negative infinity. So let's look at another example. Let's look at number 9. So number 9, we have negative 1 over x minus 1 squared. So negative 1 over x minus 1 squared. First thing first, remember we're not going to factor first. We're going to plug in our 1 first. So plugging in our 1 first, we get negative 1 over 1 minus 1 squared, which 1 minus 1 would just be 0. And 0 squared, like anything else, is just 0. So this would give us negative 1 over 0. So now that I know it is that divide by 0, I'm going to go back and look for my vertical asymptote. I have that x minus 1 squared, but I don't set both x minus 1's equal to 0. I only set the 1. So x minus 1 is equal to 0. Add 1, and we get x is equal to 1. Okay, so our vertical asymptote once again is that x is equal to 1. Notice we have that little plus sign, which means we are approaching from the right. So I'm going to plug in a number to the right of 1. So a number just to the right of 1 is 2. So we can plug in 2. So negative 1 over 2 minus 1 squared is equal to, so 2 minus 1 is 1. So negative 1 over 1 squared. 1 squared is just 1. So once again, negative 1 over 1, which is equal to negative 1. And so once again, I got negative 1, which means once again, I'm going to be approaching negative infinity. All right, so I want you to go ahead and pause the video again and go ahead and try both 10 and 11. On 10 and 11, just something to keep in mind. Remember, we always plug the number in first. So plug the number in first for number 10 and number 11, see what's happening. Then if you get that 0, look for your vertical asymptote. You might need to factor, you might need to do something to simplify first, but always plug the number in first. All right, y'all, so hopefully you figured out number 10 and number 11. So number 10, we plug in 1, we get that negative 2 divided by 0, which is a no-go. I did go ahead and factor in this one just to see if we get anything to cancel out. We don't, but then we can take that x minus 1 in the bottom, we can set equal to 0, add 1 and add 1. We get x is equal to 1 is our vertical asymptote, which matches up with the limit we're approaching. So now that I know we are approaching a vertical asymptote, it's either positive or negative infinity. We're approaching from the right. So I plug in a number just to the right of 1, which would be 2. Plugging in 2, we get negative 2 as our final answer. Negative 2 is going down towards negative numbers, so we get negative infinity. Okay, and remember, y'all, for all of these questions, if you just want to check yourself, you just want to kind of make sure you're doing everything right, you can use your graphing calculator to graph these, so you don't have to graph them by hand every time, and you can see and check to be like, okay, yes, this is the correct answer, I did everything right. You can always use it as kind of a check for yourself. All right, number 11. So number 11 was a little bit of a trick question. I might apologize if I kind of stumped you. But when we plug in 1 right away, we actually get 0 over 3, which we've talked about this before. 0 divided by a number is just equal to 0. Okay, a number divided by 0, that's no good. But 0 divided by a number, that's totally fine. So this one, our answer is actually 0. We may or may not have a vertical asymptote at 1. It looks like we don't because we don't divide by 0. But we don't have to go back and factor and try to find out. Okay, we plugged in our number, we get 0, we're good to go and good to move on. Okay, we're going to pivot just a little bit, y'all, And we're going to look at limits at infinity. So the difference here, the other ones are limits equal to infinity. These ones are our limits as they go towards infinity. So we're going to graph our function 3x squared over x squared plus 1. And then we're going to find our two limits, the limits as we go towards positive infinity and the limit as we go towards negative infinity. So we're going to use our graphing calculator again. We don't have to graph this one by hand. So 3x squared over x squared plus 1. 3x squared over 3x squared over x squared plus 1. We're going to graph it, and it does something weird, a little bit weirder than what we've seen with any rational function, but we can see that it is basically hugging its horizontal asymptote of y is equal to 3. So we're going to add that onto our graph. Okay, and so just like we said, that 3 that it looks like this graph is hugging, it is hugging that horizontal asymptote because from what we remember from our rational functions, this is an x squared over x squared, so it is an EATS. That is a very bad EATS. So it is an EATS DC situation, and EATS DC means we divide the coefficients, so we actually divide 3 and 1. So our horizontal asymptote would be y is equal to 3. Okay, so knowing that, let's look at our actual graph. So as it goes out and it approaches to the left and to the right, it goes to that horizontal asymptote. So if we kept going forever, if we kept going all the way to the right to positive infinity and all the way to the left to negative infinity, it's going to keep hugging that horizontal asymptote. It's going to get closer and closer and closer, but it's never going to cross it. It's never going to go above it. So our limit, both as we're going towards positive infinity, that's A, and both as we're going towards negative infinity, is equal to 3. So the big key thing that we want to get from this is that limits that are going towards infinity, positive infinity or negative infinity, and it's a rational function, they're going to approach their horizontal asymptote. So let's remind ourselves a little bit about how to find our horizontal asymptote. So if the degree of the numerator is less than the degree of the denominator, then the limit of the rational function is 0. And that is because numerator is less than the degree of the denominator. That is our BOBO. Which means bigger on bottom, y is equal to 0. Okay. And then number 2, if the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is whatever our coefficients are divided. Because remember, if they are equal, that's our EATS. Which means our horizontal asymptote is y equals a divided by b, whatever those asymptotes are. And then last but not least, if the degree of the numerator is greater than the degree of the denominator, then the limit of the rational function is infinite. And this is because, remember we talked about the numerator being greater than, that was our Botten situation. And Botten means there was none. We didn't actually have a horizontal asymptote. And that's why we're going out towards positive or negative infinity, because as we go out to the right and out to the left, it goes towards positive or negative infinity. It keeps going forever. Okay, so let's look at a couple of examples here real quick. So we have 13, we have 2x minus 1 over x plus 1 is the limit as x approaches infinity. We're comparing those x's, so x over x is going to be an eats situation. So that means we divide the coefficients, in this case, for our horizontal asymptote. So y is equal to 2 divided by 1, which is just equal to 2. And because our horizontal asymptote is equal to 2, our overall limit is equal to 2. Relatively straightforward. If my pad will cooperate with me, which it's choosing not to. Okay. So that is all there is to it with these horizontal asymptote ones, y'all. Notice I didn't have to plug anything in. I didn't have to do anything crazy. I just found the horizontal asymptote. So let's look at 14. 14, we have the limit as x approaches infinity of 2x plus 5 over 3x squared plus 1. Once again, I am comparing the exponents. So it is 1 over 2. So that is definitely a bigger on bottom or a bobo. Which means our horizontal asymptote is y is equal to 0. Okay, and if my horizontal asymptote is y is equal to 0, then my overall answer is y is equal to 0. Nothing crazy. Easy as that. Okay, let's do one more, and I'm going to let you practice the rest here on the notes. If my pad will cooperate. Okay, so we're going to skip around real quick. We're going to do 16. So 16, we have the limit as x approaches infinity of 2x cubed plus 5 over 3x squared plus 1. Okay, so in this case, a little bit different. Oop, wrong color. We have 3 over 2. So comparing our exponents, and yes, we are still comparing the exponents. It's not that 2 over 3. So 3 over 2. So that is actually a bottom situation because it is bigger on top. Okay, so bigger on top means we do not have a horizontal asymptote. So our horizontal asymptote is none. Okay, so because we don't have a horizontal asymptote, that means our answer is positive or negative infinity. So because it is positive or negative infinity, we got to figure out which one it is. And kind of just like with our vertical asymptotes, where we plug in a number just to the left or just to the right of the vertical asymptote, we're going to plug in a number depending on which infinity our limit is approaching. So our limit is approaching positive infinity. So I want to plug in a number going in that direction. And I want to plug in a number that's going to be pretty easy for me to evaluate. But is positive. It's going to give me a pretty good idea of what value I'm going towards, positive infinity or negative infinity. So I'm going to go ahead and plug in 10. 10 is going to be sufficiently far enough away in that direction to kind of give me a good idea of what's happening. And it's going to be fairly easy to do some math with. So plugging in 10, 2 times 10 cubed plus 5 all over 3 times 10 squared, and then plus 1. And of course, my pad's decided to no longer cooperate. Okay, so plugging this in, 10 cubed, that's 1,000. So this would be 2 times 1,000 plus 5 over 10 squared is 100. So 3 times 100 plus 1, which, simplifying that just a little bit, 2 times 1,000 plus 5 is equal to 2005. 3 times 100 plus 1 would be equal to 301. Okay, and I don't even need to simplify this. We can already look at this. What number does it look like? Well, I'm definitely getting a really big positive number. So this one's going to be headed towards positive infinity. So all you have to do on the bottom ones is you need to plug in positive 10 or negative 10, depending on which infinity you're going towards. So if you're going towards positive infinity, you're going to plug in positive 10. If you're going towards negative infinity, you're going to plug in negative 10. Simple as that, straightforward as that, no big deal. All right, y'all, I'm going to go ahead and let you practice these other 4 real quick. And so you pause me, and then when you're done, you can come back and you can check the video, okay? All right, y'all, so let's look at these. So we got 15, 17, 18, and 19. 15, relatively straightforward, squared over squared. So we divide the coefficients of 2 and 3. So we get a horizontal asymptote of y is equal to 2/3, which is our limit, 2/3. Okay, that one's really simple. 17 is another one of those bottom ones. It is 2 over 1, so that is definitely a bigger on top. We're approaching positive infinity on 17, so we're going to plug in positive 10. So plugging in 10, simplifying all the way through, I got 160 over 11, which is positive. So we're going towards positive infinity. All right, 18, we're going, x is approaching negative infinity of 2x squared minus 4x over x plus 1. So same thing, it's a button, x squared over x. So no horizontal asymptote. So I'm going to plug in positive or negative 10 to find out which infinity. Because I'm going towards negative 10, or negative infinity, I plug in negative 10. Simplifying this one out, we get 240 divided by negative 9, which is a big negative number. So we're going towards negative infinity. And then last but not least, we got 19. We have the limit as x approaching negative infinity of x cubed, which is just a cubic function. So if you know the shape of it, you probably already know what it's doing as we go towards the left. But we can still treat it like a button. We're going towards negative infinity, so we're going to plug in negative 10, which gives us negative 1,000, which is definitely a very big negative number. Okay, y'all, that is pretty much it with our infinite limits. We have the 2 different types. We have the ones where you find the vertical asymptote, and we have the ones where you find the horizontal asymptote. They're both very similar, but just a little bit different. Okay, if you have any questions, feel free to come to tutorials or ask me in class. Y'all have a great day.